Okay, next we have barium chloride plus K2SO4 to give barium sulfate plus KCl. So what I want you to pay attention to is what happens when you have complex ions. Usually when you have complex ions, you want to treat it as a whole. You don't want to count the individual elements because it's too much, right? You don't want to keep track of that many elements. So for example, sulfate, right? You can just put a bracket over here, right? And this SO4 is kind of like one unit, right? And you can count the number of SO4s, right? Like for example over here. So this SO4 is already balanced already. You don't have to care about it, okay? What you want to care about is like this potassium over here. There's 2 potassiums, so there's most likely a 2 over here. This 2 will mean there's 2 chlorines, which is balanced over here, and you realize this actually already balances this whole equation very nicely. Okay, next you have calcium oxide plus hydrochloric acid to give calcium chloride and H2O. So you want to most likely balance the calcium first, but this is balanced already, right? And then you want to balance the oxygen, but this is kind of balanced already. So what's left is just the H and the Cl. There's 2 Cls and 2 H on the right, so you just add a 2 over here. Very straightforward. Another example here is copper plus oxygen to give CuO, right? Here it's pretty simple, right? You already have copper that's balanced, right? So you want to balance the number of oxygens. So here there's 2, so you need to have 2 on the right, so there's 2 here. But remember, when you put a number here, it means you're editing the number of copper on the right, so you have to put a 2 as well over here to make sure it's all balanced.